Hello, my name is Greg Gibson. This is my 8th year teaching at ICS and 11th year teaching overall. A little bit about myself. Teaching is my second career. Initially, I was an electrical engineer, worked in the area here at Fluke Corporation up in Everett and then at Microsoft Corporation for a total of 17 years. I did design engineer work, I did program management work, got back into engineering, got back into business management where I was managing program managers, engineers, software development, etc. After 17 years, I was a little burned out with high tech, and we had some other aspirations in our family. And one of the things we did in the transition to teaching is we took our family, at the time our kids were in kindergarten and third grade, and we moved to Honduras. And we volunteered at a school right outside the city dump in Tegucigalpa, Honduras. Amazing experience learning Spanish for myself. My wife was fluent, but I was learning Spanish from the beginning, as were the kids, of course, and teaching in Spanish. So first time teaching and first time using the language is a very challenging thing, but incredibly rewarding seeing something that you don't see a whole lot of here in the Seattle area with the level of financial stress, and yet the joy you still see in those students and their willingness to learn and to live in a different way. After a couple of years, 2.5 years in Honduras, we moved back and I got my teaching certificate, and I've been teaching here at ICS for the last 8 years. Over the 11 years that I've taught, the 3 school years in Honduras as well as the 8 years here, I've taught almost every math and science class or every math class and physics class that you can think of. I'm only missing a couple of the math classes, and I cover a lot of that content in the physics classes or the computer science class. Outside of work, I've been married for 22 years. I have 2 children. One is a sophomore in college studying animal science to become a vet, and one is a junior at Lake Washington High School. So I sit through these curriculum nights from the parent perspective as well as giving them from the teacher perspective. So my kids are about the same age as our students. And I love all things sports. I love watching sports. I love playing sports. I love getting outside and doing active things. If you want to get a hold of me, the best way to do that is via email. You can, of course, call the school and they can get a hold of me as well. But email is the best place to start. This year I'm teaching AP Physics 1, which is a new flavor of physics for me, and Computer Science A. It'll be my 4th year teaching Computer Science A. So let's talk specifically about AP Physics 1. So I have taught algebra-based honors physics to ICS 9th graders for many years, and that is actually the foundation for AP Physics 1. When I taught honors physics, we started with the AP Physics 1 syllabus. We never called it AP Physics because that would scare 9th graders, but they essentially took the AP Physics course. The main difference between that course and the course I'm teaching this year is that this course will be targeting completion just after spring break in order to be prepared for the AP test. So we're going to go a little faster pace than what I taught this material to 9th graders. I have taught calculus-based AP Physics for the last several years additionally. This course is very different from the calculus-based course and is targeted at a little bit simpler, a little more approachable level of physics. The physics we teach here is Newtonian physics, and it's really targeting the physics that you see in your everyday life. It is not covering modern day physics, and modern actually meaning almost everything in the last 100 years in the field of physics. So we're not doing Einsteinian physics of relativity, we're not doing quantum physics, we're not doing nuclear physics, those sorts of things, but it's the everyday things that you're experiencing. What happens when a ball flies through the air? What happens when a bat hits that ball? Those sorts of things is the focus of our physics course. Computer science, this is, I think it's the 4th year that I've taught computer science. AP Computer Science A is a great course. It's equivalent to the very first course that UW or lots of colleges teach in their computer science department. So it starts under the assumption that students have no knowledge of computer programming, have never programmed in any language. One of the challenges that I always have in this course is my students are typically split in about thirds, and this year is no exception, where about a third of the students have never programmed before in their life. About a third say they're already proficient in Java. Now, time tells us whether they really are proficient in Java. But the interesting thing is we've had some of the highest AP test scores of any class in the school district from ICS's Computer Science A. And there is no correlation between the performance on the AP test and how much Java experience those students had prior to this course. So we start from the very beginning and we build them up on how do computers work, how does Java work, what's object-oriented computer programming, what's procedural decomposition of programming, and build them up to the point where they're doing most of the common basic computer science algorithms using Java as a tool to get there. A couple things that I really enjoy about these classes is actually the post-AP test time when we have a little more freedom on the curriculum. From a physics standpoint, what we'll typically do after the AP test is do an engineering physics project. In years past, we've done race cars out of mousetraps, we've done tractor pull competitions, we've built elevators, things of that sort. From a computer science standpoint, what I'm planning to do this year is 2D gaming. So we'll teach the students graphics, which is one thing that's not included in the curriculum for AP Computer Science A, which is the only missing piece to do sort of 1980s era computer games. So last year, some of our students built Asteroids and Pac-Man and Missile Command and that kind of games, and we'll get to develop those sorts of games. On the physics side, time will tell as to how much in-person we'll be doing and how we might do such an engineering project from remote, but we'll cross that bridge when we get to second semester. Look forward to a great year.